All right, another area volume one. Definitely looks more like volume than area, but we'll look at the question. So here we have a cylinder. This comes from 2019. And let's read it. So a cylindrical barrel, cylinder with a diameter of 2 feet, contains collected rainwater as shown in the figure above. The water drains out through a valve at the bottom. So it's going to come out. That's not shown. The rate of change of the height of the water in the barrel with respect to time is this, where h is measured in feet and t is measured in seconds. And they give you the volume formula for a cylinder, so you don't have to have that memorized. So one at a time. Some of these will be easier and some will be more complicated, and that's life. So this is 2019, fresh piece of paper. This is question number 4, which means it's no calculator, so I'm not using Desmos. And the first question is, find the rate of change of the volume of the water in the barrel with respect to time when the height is 4. So the first is the rate of change of volume. So step 1 is I'm going to write down the volume formula. And then I'm going to see, is there a way to take away a variable? Is there a constant as we look at it? So if you look at the cylinder, as water is going down, the radius never changes. So if the diameter is 2, the radius is 1, and as the height changes, the radius never changes. So before I do the derivative, I can put in what the radius is at all times. So at all times the radius is 1, and I can put that in. I'm going to simplify it. So 1 squared times that. And now I have an equation I can take the derivative of. So when I take the derivative, it's with respect to time. So the derivative of v is 1, but it needs the hook. The derivative of pi times h is pi. So if the derivative of 2h would be 2. So pi h is pi. And then it needs the hook dh by dt. Then I'm going to plug in for the height. It says when the height is 4. So I got pi. Now, what do I use for dh by dt is what was given in the question. And I'm going to plug that number in for h. So I'm going to type in negative, or write negative 1/10, and then the square root of 4. I don't have to simplify that, but I do have to have units. So height, and if I look carefully, it's feet. So it's just feet, not feet cubed, because it's not volume, just feet per second. You don't need to write a sentence for that one, but you do need to have the answer with the correct unit. Part B. It says, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? So for part B, we're going to take the derivative of the derivative. So we have the derivative here, and I'm going to write it calculus friendly. And then I'm going to take the derivative of that derivative to know if that rate is increasing or decreasing. So I'm going to go 1/2 times negative 1 over 10. So that's negative 1 over 20. Going to subtract 1 to the exponent, and then it needs the hook dh by dt. And then we have a number for h. So then I'm going to plug in what h equals. So h equals 3 in this case. So I have negative 120. I have 3 to the exponent negative 1/2. And then for the derivative, I'm going to use that derivative formula here. So negative 1/10 and the square root of 3 in this case. I don't have to simplify it too far, but I do recognize a negative times a negative together, that answer, negative 120, 3 to that exponent that's a positive value, negative 1 over 10, that this answer is greater than 0. So since that is greater than 0, the rate of, and I'm going to use the words in the question, the rate of change of the height of the water with respect to time is increasing. And we explained why it's increasing, because you could say that this value is positive or this value is greater than 0, therefore the rate is increasing. So you're asked for the rate of a rate. You have to take the derivative. All right, last one, part C. Turn my page. In part C it says, at time t equals 0, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So we're just looking at the derivative for h, and we're going to do FRQ here together. You guys are experts at that. So we're going to write dh by dt and then we're going to solve this differential equation. So first of all, we're going to multiply and divide to get the variables together on one side. So I'm going to divide by the square root of h. So I'm going to divide by the square root of h. I'm also going to multiply by dt. So I divided and I multiplied, so the h's are on one side and the t's are on the other side. I'm going to write this friendly, and then I'm going to integrate it. So I'm going to add 1 to the exponent and divide. Instead of dividing by a half, I'm going to multiply times the reciprocal to make it easier to work with, because it's not the end of the question. Negative 1/10 is just negative 1/10 plus c. It says that initially the height, 0, it is 5 feet. So we're going to plug that point in. So 5, and you could leave it as 5 to the 1/2 is the height, and 0, that means that's what c equals, because negative 1/10 times 0, that means that c is left there. So now I'm going to write this equation again, and we'll write it algebra friendly in a moment. So if I'm going to solve it, let's write it algebra friendly so you can see how you're going to solve for h. So to get h by itself, we're going to divide by 2. Notice I'm not trying to make this complicated. So I have negative 1/10 t plus 2 root 5 divided by 2. Super easy. How do I undo squaring? Square rooting as I square. So this whole thing I'm just going to square, and I am done. And that's it. That was the last question. Mr. G Math over and out. You can do this question a second time or a third time until you feel like you understand it better. Good job doing your work today.